welcome to today's lesson on the gradient of a straight line, and we're going to look at today how do we find the gradient of a straight line given a graph, and what is the gradient? So we'll start by answering that question. What is the gradient? Well, the gradient describes the steepness of a straight line, so we can fill in there on the worksheet. It describes the steepness of a straight line. So what that means is if we look at these two graphs here, we will be describing how steep the line is. Okay, so if you can see the first line, the red one, currently it has a steepness that looks like that, but if I change that steepness by rotating it, we can see it gets steeper or more shallow. Okay, so we'll be looking at how do we find what the gradient is and show it as a number representation. Now, you may have seen, if you were driving in the car with your parents or just walking around, a road sign where they give a percent, and sometimes it says the gradient. Okay, it will say the gradient on the road sign. And what does that mean? Well, that's saying how steep the hill is. So if it's got a 20% gradient, they're warning you that the hill is very steep. Okay, so we're going to look at the steepness of straight lines. In maths, in your GCSEs and exam questions, we'll be looking at a straight line and how steep it is, and how do we show that as a number, and how do we find that? So we've got two lines here. We've got one that is red going in that direction and one that is blue that is going in that direction. And there we say that one of those is positive and one of those is negative. So the one that is going up is a positive gradient, okay? And the one that is going in a downward direction, the blue one, we say is a negative gradient, okay? And sometimes students find it difficult to see which one's positive and which one's negative, because you could describe both of them as going up depending on which way you're starting. If you're starting down here, that could be going up, and if you're starting here, this one could be going up. So if you always look at the line from left to right, that's how you're going to decide. So if you think about a little stick man on this line starting at left, if he walks to the right, what would happen? He goes up, so it's positive. And if we put the same little stick man on the left of this graph here, if he walks to the right, he's going to be going down. So that is a way that you could decide whether it's positive or negative if you find it difficult to decide yourself. Think of a man and think of, if he walks to the right, would he go up or would he go down? And that would describe whether it's positive or negative. But if you can just see it, that's absolutely fine. Lines that go in a upward direction have a positive gradient, and ones that go in a downward direction from the left to the right is a negative gradient. Okay, so let's talk about the gradient and its steepness. We've just discussed whether it's positive or negative, and that describes whether it goes up or down. We'll now look at how do we actually find the gradient? How do we give a number value for the gradient, and what does that mean? So I've written here, and it's really important that you remember this, that the gradient, and we call the gradient m in maths, okay? We used a generic letter m to describe the gradient. We don't use g, which makes logical sense, we use m. So the first thing that you need to remember is m is the shortened notation for the gradient. Okay, and what is m? Well, the gradient, m, equals up divided by across. That is what you need to remember. That is our formula to find the gradient from a graph. Okay, and as you've seen here, I can show that with a little diagram where if we've got a straight line, so this blue line here, if I've got 2 points on that line, if I work out how much across it is and how much up it is to get from one point to another, I can then use that in my formula, up divided by across, to get a number value for our gradient. So let's take a look and see how that works. If you look at example 1, we have got the line y equals x, and that is this red line here That is what we call the equation of a line, and that will be a lesson that is coming up after this series. And we need to find the gradient of it. So we need to find the steepness. It wants us to find the steepness, is what that's saying. It says, please find the steepness of this line. And we know, given the formula we just discussed above, that the steepness, m, the gradient m, is equal to, so m is equal to up divided by across. So I need to get myself a triangle that goes between 2 points like I've got up here, and work out how far across it is and how far up it is to get from one point to another. Now, this is where you get to make a decision, and there's one really important factor that you need to decide on which points you're going to use. You can make any triangle on this straight line, providing it falls in the following criteria. You need to pick a point that is on the grid. And what I mean by the grid, if you look in the background of this graph, there's a grid. We need to make sure if we pick a point, it is on the grid. So as you can see, that point there falls on the intersect of the grid behind. But if I pick this point here, that is a very bad point to pick because it is not on the grid. So appropriate points we could pick are this one down here, this one, this one, this one, and all the way up. All of those points are valid points that we can pick because they all fall on the grid. And that is so important. When you're drawing the triangle to help you find the gradient, you need to make sure you pick points that are on the grid. Okay, so this and this point would be a very bad point to pick to make our triangle because it is not on the grid. And as you can see, if I asked you how many across is that, well, it's really difficult to tell because it's not using the units of these full squares. Yeah, it's not 1, 2, 3 full squares. It's 1, 2 full squares and a little bit on that side and a little bit on that side. And unless you've got a really accurate graph, it's difficult to know what those little bits represent. So we're going to use a point that is on the grid, and this triangle could be as big and as small as you like, providing that it is on the grid. And I'll show you that if we use 2 different triangles, one really big one and one really small one, we're going to end up with the same gradient. We're going to end up with the same value. Okay. So let's start by picking a point. Let's just say we want to use this point here, which is a very valid point because it is on the grid. And we need to pick another point above it that is also on the grid. So we could pick, for instance, this one here. Okay. From there, we can draw a triangle to help us decide. And we need to check how far across is it to get from this point to this point, and how far up is it to get from the same 2 points. So how far across is it? And this is crucial. You have to use your scale. Okay, we have to use our scale. So it is 1, 2. It's 2 squares across, but you have to check. Does 2 squares represent 2 units? Yes, it's going from 1 on the x to 3 on the x. So that is across 2. Now, don't just fall into the trap of counting the squares, because sometimes, I'm sure you've seen it in previous examples in the coordinate lesson we did, that sometimes the scales could go from 2 to 4 to 6 to 8, and that means that 2 squares isn't 2. 2 squares would be 4. So it's really important that you check the axis, check the scale that the axis is using. In this case, we're going to be absolutely fine. 2 squares does represent 2 units, so it's 2 across. And now check the y-axis, the scale is going up. 1 square is 1 unit. So this is going to be going up also 2 units. So we can say that our gradient m is up divided by across. Okay, up divided by across. Well, how far up is it? It is going 2 up between our 2 points, and how far across is it? 2. 2 divided by 2 is 1. Okay, so that means that the gradient is 1. The steepness of our line is 1. What does that mean? It means every time you go across one unit, you go up a unit to meet the line. across 1 unit, up 1 unit, across 1 unit, up 1 unit, across 1 unit, up 1 unit. Okay, and that is what makes a straight line. If you have a consistent gradient, aka every time you go across 1, in this case you go up 1, you will make a straight line. And that's how straight lines are formed, by having a consistent gradient that follows the same pattern all the way across. So I previously said that it doesn't matter how big you draw this triangle, providing you stuck to the constraints that they need to be on the grid, you're going to get the same answer. So we can see that if we change colour to maybe a green, I'm going to put a point down here and a point all the way up here. Okay, so if I now construct my triangle from those points, we have to count up divided by across and then see if we get the same gradient. How many up is this? This is 1. Remember, we know that 1 square is 1 unit, so it's 1, 2, 3, 4, 5, 6, 7, 8. It is 8 up, and it's going to be 1, 2, 3, 4, 5, 6, 7, 8 across. So if I use this green triangle, what would I get? Well, I would get m equals up divided by across, which is 8 divided by 8. 8 divided by 8 is 1. So I get the same gradient. So, as you can see, as long as you stick to those rules of making sure the points that you pick on the line fall in the grid, you're going to get the same gradient regardless of how big or how small you draw your triangle. Okay, so again, the gradient of 1 means the steepness of this line is across 1, up 1. So we'll make that note. We'll make that note that the gradient of 1 means that every time you go across 1, you go up 1. Okay, let's make that note. Every time you go across 1 unit on the graph, you go up 1 unit. Okay, so that's our first example. What we've seen there is how do we take a straight line, use the formula that we spoke about here, m, remember is the gradient, and work out a value for the gradient. In this case, 1. Every time you go across 1, you go up 1. And we can see that. If you go across 1 unit, you go up 1. Across 1, across 1, across 1, across 1, across 1. And it makes a straight line. So we can take that understanding into different examples where, as you can see here, we discussed that a line that's going in this direction, if we've got our man here and he walks to the right, he's going to be going down, we've got a negative gradient. So how do we find the gradient of a negative line? Okay, a line that has a negative gradient. We know it's got a negative gradient because it's going down. And this is the equation y equals minus x. Well, we're going to do the same thing. The first thing we're going to write down is m, gradient. Remember, m equals up divided by across. And then we need to draw a triangle on our graph. And again, you can make this as big or as small as you like. The only difference here is I'm going to pick this point and I'm going to pick this point. And if you want to, you could pick a different point. You could, if you're following along, pick a different point and see if we get the same answer. But here, we're going to go across and then we're going to have to go down. Okay, instead of across and then up like the previous one, we're going to go across and then down. And that's how we know it's a negative gradient. So how many do we go across? Check our scale. Our x-axis, every 1 square is worth 1. So we're all good there. So it's across 1, 2, 3. And we need to go to this point here. So how many is that across? That's across 1, 2, 3, 4 squares, and every square is worth 1. So it is just simply across 4. We're going to go down to meet the point. How many down is it? Well, the y-axis, let's check. Every 1 square is worth 1 unit. So we've done our check and we can now count the squares and work it out. We've got 1, 2, 3, 4. Across 1, down 4, because 1 unit is 1 square. So we can now fill in our formula. Up divided by across. Up is 4, and across is, across is 4. Right? But we're going down 4. We're going down 4. So 4 divided by 4 is 1. Okay. 4 divided by 4 is 1. And we're going down. So all we have to do to make this gradient correct, we know that this is a negative gradient because we can see it's going down. And we can see that we had to go down here. So all we need to do is put a negative in front of our gradient. So the gradient of this is minus 1. And hopefully if you picked a different point, you would have got minus 1 as well. What does a minus 1 gradient mean? Well, very similar to what we just discussed. It means every time you go across 1, you go down 1. Across 1, down 1. Across 1, down 1. Across 1, down 1. Across 1, down 1. As you can see, it's making a straight line that is going down of a gradient of 1. Across 1, down 1. So we can add that note that the gradient of minus 1 is across 1 unit and down 1 unit. Okay, that's what that means. And it's really important that you, before you even do the gradient m equals up divided by across, that you decide whether this is a positive or a negative gradient. And if it's a negative, all you have to do is remember, I need to put a negative sign on my gradient. Okay, so 2 very straightforward examples there. We're going to look at some now where the scale is going to be different and we need to be very careful. Okay, the sort of thing that a student would fall into a trap and get the wrong answer because they weren't being careful. So example 3, we would like to find the gradient of this red line on this graph here. So what do we know? We know that the gradient m equals up divided by across. Okay. First thing you should decide, is this a positive or a negative gradient? Well, it's going up. Little stick man, if he walks to the right, he's going to walk up. It is a positive gradient. So that's that decided. I know that my answer is going to be a positive number. And I now need to pick 2 points on this graph and I need to find the gradient. So you can pick any 2 points, as discussed, any 2 points, provided that they will be on the grid, you're going to get the right answer. So I'm just going to pick this point here and let's say this point here. Okay. So how many across and how many up is what we need to decide. Well, we have to be careful here. We have to be really, really, really careful. How many across is my line here? Well, it's 2 squares across. But does that mean that it's 2 units across? Well, no. If you look at the x-axis scale, it's telling us that 2 squares is worth 1 unit. If I go across 2 squares, I've only gone across 1 unit. So it is not 2 across. Even though it's 2 squares on the grid, it's actually only 1 unit across. So we can say that it is 1 unit across, not 2. The mistake students would make here is they would count the squares and they would put 2. Okay. So checking our scale on the y-axis, what is this saying? This is saying that 1 square is worth 2 units. Okay, 1 square is worth 2 units, so we have to be really careful. 1 square is worth 2 units. Well, this is 2 squares, so it's not 2 up, it's going to be 2 squares would be 4, okay? Because every square is worth 2 units, so it's 4 up. And that changes the answer massively, okay? The answer will be changed so much by making sure that our scale is being used correctly. This is not 2 across and 2 up. It is 1 across and 4 up because of the scale. Now, we can now go and fill in our formula. up divided by across. It's 4 up and 1 across. So it is 4 up and 1 across. 4 divided by 1 is simply 4. So our gradient is 4. What does that mean? Well, it means every time you go across one unit, you go up 4. Across one unit, up 4. And it doesn't look like across 1 and up 4 when just looking at the squares in the background. But if you take attention and really focus on the scale of the x and the y axis, it definitely is 1 across and 4 up. Okay? So example 4, finding the gradient of this line. The first thing that we should look at is it positive or is it negative? Okay, well, this is a negative gradient. It is going down. So we have to remember that our answer is going to have a negative m, okay? It's going to be negative. So we just have to remember that at the very end. Same thing applies. We're going to write our formula down. M equals up divided by across, where the up and across needs to be found. So we need to find 2 points on this grid. I'm just going to pick this one here, and I'm going to pick this one here. We need to check how many far across it is and how many far up it is. And we have to be careful using our scale. So, how many across is this? Well, every one unit is 2 squares, so it's 1, 2. It's only 2 units across, not 4. Even though it looks like 4, it's only 2, because there are only 2 squares per 1 unit, and there's 2 lots of that, so it's going to be 2. How far up is it? Well, it's going to be 2 squares, and every square is worth 2 units, so it's going to be 4. It's going to be 4 up. Okay? So, up is 4, and across is 2. 4 divided by 2 is 2. So the gradient is 2, but not just 2. Remember, it's a negative gradient, so it is negative 2. Our gradient is going to be negative 2 because it's going down. What does that mean? It means every time you go across one unit, which is 2 squares, you go down 2. Across 1, down 2. Across 1, down 2. Across 1, down 2. Okay, and it doesn't look like it because of the scale of the graph, but it definitely is. So be careful. What should we write here? Something that you need to remember. Be careful. 1 square does not always mean it is 1 unit. 1 square in the grid does not always mean that it is 1 unit. Okay, we need to always check the axis, okay, or the axes. We need to check the axes. We need to make sure, what does 1 square represent? Because we've seen here that 1 square does not represent 1, and 1 square here does not represent 1, so you have to check your scale. Okay, so that brings us on to the last 2 examples, example 5 and example 6. We have a different style graph here where the graph paper is slightly harder to read. A lot of students really find this difficult, but we'll jump in and have a look. Find the gradient. Well, the gradient is m equals up divided by across. Let's check our scale and check whether this is a positive or a negative gradient. So this line is clearly going up, so it's going to be a positive gradient. And we need to check our scale. Well, 1 unit is worth 1 of these big squares. Okay, so 1 unit across is 1 big square. That means one of these little squares must be worth a half. So we just have to be clear on that. And we also have to be clear that on the y-axis, 1 unit is one of these little squares. Okay, so on the x, 1 unit is a big square. On the y, 1 unit is a little square. Okay, so we have to be really, really clear on that. Now we can go. Now we've made that decision and we understand that the scale is not 1 square is 1 unit, it is different, and we need to be careful of that. We can draw 2 points. So I'm just going to draw a point here and a point here. And again, you can draw these points wherever you want, providing they are on the grid, where the grid crosses each other. So let's check. Let's check with our triangle. How far across is this and how far up is it? Well, across is, we're going from 0 to 2. So it's going to be across 2. And we're going up 1 little square, which is worth 1 unit. So it's across, up 1. So we're filling our formula. M equals up divided by across. Well, up is 1 and across is 2. So the gradient of this line is a half. What does that mean? So you're allowed fractional answers. You could, if you wanted to, you could write or 0.5. I prefer a half, and exam questions and lots of maths questions use fractions as gradients. And I'll explain why. Why do we like to use fractions? Well, what do we know the bottom of this fraction means? Across. And what do we know the top means? Up. So the numerator means up, the denominator means across. So if I had to describe this gradient of a half, I could say that this means 2 things. It could mean across 2 and up 1. So that means every time you go across 2, you go up 1. Or it could mean every time you go across 1, you go up a half. Now it's much easier to just use the fraction and say, right, the bottom's 2, so that's across 2, the top is 1, so that's up 1. And you can see here, that's how we got it, across 2, up 1, across 2, up 1, across 2, up 1. Okay, so do not be scared of fractional gradients. Leave them as a fraction. Don't turn them into a decimal. It's much easier to leave it as a fraction. Okay. So if you had this, if you had m equals 2/3, what does that mean? Well, that means every time you go across, remember across is the denominator, across 3, you go up 2. The gradient of 2/3 would mean across 3, up 2. Okay, so that brings us on to our last example. So we've seen positive, negative, different scales, fractional gradients. Don't be scared of them. They're fine. And you're allowed them. Let's look at example 6, where we have clearly a negative gradient. That's the first thing you should check. We've got a negative gradient there. And we have a scale where 1 square is worth 1 unit on the x and 1 square is worth 1 unit on the y. And it says find m. Well, you need to know that m means gradient. So I can say that m equals up divided by across. Let's go and discover what our up and across is. We need to pick a good point. Remember, this would be a bad point. Right there is a terrible point because it's not on the grid. However, here, just up next to it, it's a really good point. And maybe we'll pick this one here. And again, you can pick any points providing they are on the grid. And we're going to check how far down and how far across is this. And you can draw your triangle the other way if you want. So I've drawn mine down and across. You can draw yours across and then down. It's exactly the same. So it doesn't matter which way your triangle's drawn. How many down is this? Well, 1 square is worth 1 unit, which means it is down 4 squares. So it is down 4 or up 4, given our formula. How many across is this? Well, 1 square is 1 unit. So we've got 3, 4, 5, 6. We've got 6. So up divided by across. Up is 4. And across is 6. Well, we've got a fractional answer again. We can simplify this. This would be 4 over 6 simplifies to, well, what goes into 4 and 6? 2. 2 goes into 4 twice, and 2 goes into 6 3 times. So our gradient is 2/3. What does that mean? That means you go across 3 and then up 2. The gradient is 2/3. So what have we seen here? If we compare this gradient here, this gradient's a half. Look how steep this line is, right? If we look at this line, it's about that steep. And if we look at a line with a gradient of 4, yeah, we found the gradient here is 4. What could you say? That it is way steeper. So a lot steeper. So the conclusion that we can make is if the gradient number is bigger, the steeper the line. The bigger the gradient number, the steeper the line. And the smaller the gradient number, the more shallow the line. Okay, so that is your introduction of gradients, what they are and how do we find them. This is what you need to remember. M is the gradient, up divided by across, and making sure you're checking the scale and drawing correct triangles that fall on the grid. If you check the description of this video, you will find some practice questions to follow up on this, and you'll also find the answers. And if you need to go back and look at any other lesson, you can find all of those on the YouTube channel, or you can have a look at my website where they are organised with year groups and topics. Thank you for joining in. Hopefully you learned something, and hopefully this stream wasn't too laggy. I saw that it may have been glitching a little bit, and I'll try and sort that out and see you in the next one.